Hello students, this is a brief explanation about chapter 12, grouping of lamps. In this chapter we will talk about two types of grouping. There are two basic types of grouping of lamps in an electric circuit. We have a series grouping or parallel grouping. In a series connection, the components are connected one next to the other. As you can see here, three lamps بيكونوا كلهم على نفس الواير أكيد with a battery. The electric current through each of the components is the same. It means if we connect an ammeter in the circuit, we will get the same value. The electric current means an ampere اللي هي بنستعملها ammeter وبنحطه in series بقلب السيركت. So the electric current, which is I, if the lamps are connected in series, it will be the same in all the lamps. So if the ammeter reads 2 ampere, so the first lamp will take 2 ampere, the second lamp also, and the third lamp also, because they are connected in series. This is called the law of uniqueness of current in a series circuit. The electric current is the same. For the voltage across the components is the sum of the voltages across each component. It means if we connect a voltmeter across the first lamp, the voltmeter will read the voltage of the first lamp, which can be different from the second lamp and different from the third lamp. So the voltage across the battery is the sum of the voltages across the three lamps if they are connected in series. So if the first lamp takes 2 volts, the second lamp, for example, 3 volts, the third lamp also 2 volts, they will have a sum of 7 volts, so the battery will be 7 volts. This is called the law of addition of voltages in series. The second type of connections is a parallel connection. In a parallel connection, the components are connected parallel to each other, as we can see in the figure. The lamps are connected in parallel to each other. The voltage across each of the components is the same, so the voltage across each lamp is equal to the voltage of the battery. U equal UL1 equal UL2 equal UL3, so they have same voltage. So if the dry cell is, for example, 10 volts, each lamp will take 10 volts. This is the law of uniqueness of voltages in a parallel connection. For the electric current, which is an ampere, the total current is the sum of the currents through each component, which means that I equal I1 plus I2 plus I3. This is the law of addition of currents in a parallel circuit. It means in parallel the voltage بيكون هو ذاته بكل لمبة إذا كانوا connected in parallel، والelectric current اللي هو ال I بيتقسم على كل لمبة. فالelectric current بيتقسم إذا كانوا in parallel والvoltage بيكون equal كلهم لبعضهم. هلا بنشوف example عن هذه الشغلة. Example 1. In this electric circuit هون عنا battery 2 lamps L1 و L2. قالوا لنا بأول part mark the correct direction of the electric current I in the circuit. أكيد direction نحن بنعرف إنه هي من البوزيتيف بول بتمشي بتروح على النيجاتيف بول. Complete the figure by drawing the connecting wires needed to measure the current carried by the lamp L1 by using an ammeter shown in the figure. So this is an ammeter. So we connect the COM terminal to the negative pole of the battery, and A, because it's an ammeter, we can connect it here, so the ammeter will be beside the lamp L1. أكيد the ammeter is connected in series, so we can put it here or here is the same. Specify the current I sent by the dry cell and I prime carried by the lamp L2. Because the two lamps are connected in series, so they will have the same current. As we said before, electric current بيكون هو ذاته بكل electric circuit لأنه هو in series. ف I equal I1 equal I2 equal 0.5 أمبير، لأنه هيك محطوط عنا على الأميتر هون على الشاشة. A second example, in this electric circuit, three lamps L1, L2, and L3 are connected to a dry cell delivering a voltage of UPN equal 12 volts when K is closed. So, when a voltmeter is connected in parallel with lamp L2, it indicates 8 volts. لكن لما حطينا فولتميتر على هيدي اللامب أكيد عطتنا 8 volts. لكن الفولتج across the lamp L2 is 8 volts. بأول سؤال part A قالوا لنا the voltage across K is UPA equals 0 volts. Justify. Since it's a closed switch, so the voltage across a closed switch is 0. Part B, find by stating the law used the voltage across L3 and deduce UBC. The voltage across L3 is equal to the voltage across L2, which is 8 volts, because L2 and L3 are connected in parallel. L2 and L3 are connected in parallel, so they have the same voltage. Law of uniqueness of voltage. أما part C قالوا لنا calculate by stating the law used the voltage UAB across L1. L1 is connected in series with L2 and L3. So if you want to calculate the voltage of L1 by using the law of addition of voltages, we subtract the voltage of the battery from the voltage of L2 or the voltage of L3 because they are the same. So 12 volt of the battery minus 8, you will get 4 volts. فبتطلع L1 عم تاخد 4 وكانت البطارية عم تاخد 12 و L2 عم تاخد 8. 12 minus 8 بيطلع لنا 4 volts. Law of addition of voltage.